Hello, Dr. Zorn. This is the Hardcopy Homework 1. So this is the problem statement and a drawing of the picture. And by the way, this is the first problem. And this is a free body diagram showing the angles of the forces and their U and V components. Methods, assumptions, and formulas. So to solve for this problem analytically, we would use the law of sines. That would give us the U and V components of both of the forces, F1 and F2. And then to solve for the resultant force, we would first have to add the U components of both of the forces, and then we would have to add the V components of both of the forces, and that would give us the U and V components of the resultant force. And to solve for the magnitude of the resultant force, we would square the U and V components, add them, and then square root that value. And then to solve for the angle of the resultant force, we would use the inverse tangent formula. So resultant force is V component over resultant force is U component. That would give us the angle of the resultant force. And for calculations and results, I've done all this here. So first we use the law of sines to find the U and V components of F1 and F2. And then we would add each component together to find the components of the resultant force. And we'll just be using that same formula again, the distance formula to find the magnitude, and then the inverse tangent formula to find the angle of the resultant force. So that's solving this problem analytically. To solve for this problem graphically, we could say that 1 centimeter is equal to 100 newtons. And if we measured each of the U and V components of the forces, F1 and F2, we would get these values. Centimeters and newtons. Now for F2U, when we calculated the problem analytically, we got 482.2 newtons. Now if we look at the diagram, see that F2U right here, this line, is about 4.9 centimeters, or in our case, 490 newtons. For F2V, we calculated negative 376.2 newtons. If we look here, it is about 3.8 centimeters, so 380 newtons. So for F1U, we calculated 159.6 newtons. If we look here, hope you can see that, it is about 1.55 centimeters, so 155 newtons. And for F1V, we calculated 205.2 newtons, and if we look here, we would get about 2 centimeters. So that's 200 newtons. Pretty close. So this is the second problem, and for that, this is the problem statement with the drawing of the problem. This is a free body diagram with each of the forces and the angles of the diagram, and also with the axes. And so same thing here, we use the law of sines to calculate the sides AB and AC. Once we have those sides, and the force is given to us, 500 newtons, so once we have those sides, we can use the law of sines to calculate, as I said before, we can use the law of sines to calculate the sides. And we already have the force, 500 newtons. And that's it for that problem. So again, law of sines, both problems. And that's it. All right, thank you so much. Have a good one.